Welcome you all for the CET physics classes. So today we'll discuss the current electricity synopsis first. Before going the multiple choice questions, we'll go through the synopsis. The rate of flow of charge through a cross section of some region of a metallic wire is known as the current through that region. Okay, first we'll define the current, that is the rate of flow of charge through a cross section of some region of a metallic wire or electrolyte is known as the current through that region. If the rate of flow of charge is constant, then the current at any instant is given by the differential limit, like I is equal to dq by dt. If the charge q flows through the circuit at time t, then the I is equal to q by t. So q you should write as a NE. So that is, if the I is equal to q by t, that equal to NE by t, where the N is the number of charges, E is what? The charge on the electron. Then the SI unit of current is ampere. Not only ampere, sometimes you may use the coulomb per second also. Okay. Then the metallic conductor, the current is due to the motion of electrons, whereas the electrolyte and the ionized gases, both electrons and positive ions, move in opposite direction. The direction of current is taken as the direction in which the positive charges moves. Okay, so this is very important. Whenever you should connect the circuit, okay, then if you pass the current, the direction of current is taken the direction of positive charges. Okay, so positive of the battery to the current is moving, and not only the direction of electron, that is the direction of positive charges. In conductors, the although the current is only due to the electrons, and the current was earlier assumed to be due to positive charges flowing from the positive of the battery to the negative. Okay, whenever you should connect the circuit, the positive of the battery to negative of the battery, the current is flowing. The direction of current, therefore it is the opposite to the flow of electrons. Okay, so the direction of current is what? It is the direction of positive charges, and it is opposite to the direction of electrons. In the absence of an electric field, the free electrons in a metal move randomly in all directions, and therefore their average velocity is zero. Whenever the circuit, the electric field is zero, current is zero, then average velocity is also zero. When the electric field is applied, they are accelerated opposite to the direction of the field, and therefore they have a net drift velocity in that direction. However, due to the frequent collision of the atoms, their average velocity is very small, and this average velocity is with which the electrons move in a conductor under the positive potential difference is known as drift velocity. Okay, drift velocity is what? The average velocity with which the electron moves in a conductor under the potential difference. Then suppose capital E is the applied field, small e is the charge on the electron, small m is the mass of the electron, tau is the relaxation time. Then the time interval between two successive collision is a relaxation time. Then the acceleration of the electron is A is equal to E by m. Okay, that is E by m. Since the average velocity just after a collision is 0 and just before a next collision it is a tau, and it is the drift velocity is taken, Vd is equal to E tau by 2m. Okay. So if you remember these formulas, okay, that is the Vd is equal to E tau by 2m. If the I is the current through the conductor and N is the number of free electrons per unit volume, then it can be shown that I is equal to NEA Vd, and the mobility mu of the charge carrier is defined as the drift velocity per unit electric field, mu is equal to Vd by E. Then we will see the Ohm's law and resistance. Okay, the physical conditions such as temperature, pressure, stress, strain remains unchanged. Then the current flowing through the conductor is directly proportional to the potential difference across its ends. So V is directly proportional to I, or V is equal to IR. That is the equation for Ohm's law. The constant of proportionality R is known as the resistance of the conductor, and this law holds for metallic conductors. According to Ohm's law, the graph between V and I is a straight line. Ohm's law is not valid for semiconductors, electrolytes, and electronic devices, etc. Okay, so that is what the V is directly proportional to I, that is the voltage is directly proportional to current. Okay, current is directly proportional to potential difference. V is equal to IR is the equation for the Ohm's law, and the constant of proportionality R is a resistance of the conductor, and that is holds for good for metallic conductors, and the ohmic and non-ohmic devices. According to Ohm's law, the graph V and I is a straight line. Ohm's law is not valid for semiconductors, electrolytes, electronic devices, etc. These are known as non-ohmic and non-linear conductors. The resistance of a conductor is measure of opposition offered by the conductor to the flow of current. Okay, resistance is what? It is opposition offered by the conductor to the flow of current. This opposition is due to the frequent collision of electrons with the atom of a conductor. The resistance of a conductor is directly proportional to length, and it is inversely proportional to area of cross section. Therefore, the R is directly proportional to L by A, and R is equal to rho into L by A, where the constant rho is a constant of proportionality, and that is depends on the nature of the material, and that is known as resistivity or specific resistance. Okay, rho is a resistivity or specific resistance of the material, and the SI unit for the R resistance is ohm, and the resistivity SI unit for resistivity is ohm meter. SI unit for resistivity is what? Ohm meter. Then the resistivity of material of a conductor is given by rho is equal to m divided by n e square tau, where n is the number of free electrons per unit volume and tau is a relaxation time of a free electron. Its value depends on the nature of the material of the conductor and its temperature. Okay, so the n is a number of free electrons per unit volume, tau is a relaxation time, and the value depends on the nature of the material of the conductor and its temperature. Then the inverse of resistance is known as the conductance. Conductance is what? Inverse of resistance or reciprocal of resistance, and the SI unit of it is per ohm or Siemens. Okay, per ohm or Siemens. Then the inverse of resistivity is known as conductivity. Inverse of resistivity is a conductivity. Therefore, sigma is equal to 1 by rho, and the SI unit for conductivity is per ohm per meter or Simon per meter. Then the variation of resistivity of materials with temperature. If rho naught and rho T is the value of resistivity of 0 degree Celsius and T degree Celsius respectively, then over a temperature range that not to be large, and we have the approximately rho T is equal to rho naught in bracket 1 plus alpha T, where the alpha is a temperature coefficient of resistivity of the material. Okay, so that is the temperature coefficient of the resistivity of the material. Consequently, we have the resistance approximately RT is equal to R naught in bracket 1 plus alpha T. So in this video, we'll stop here only. Then after this YouTube video, okay, I will prepare another one YouTube video that is depends on the only this synopsis. Okay, I will solve some multiple choice questions. Okay, then we'll see that in next video. Till then, take care. Bye bye.